All right, so why do elements bond? Or what is a bond is a better way to say it, and then we'll say why. So here's kind of the definition of a bond. It's when two or more elements or atoms, I think I used the word elements this morning, atoms is a better word, but two or more atoms share or transfer. Now, who remembers? What part of the atom does the bonding? The electrons. What type? Or which electrons? Valence, right. So two or more atoms share or transfer valence electrons. And I use the analogy of food. Everybody likes food. Okay, if I have a whole bunch of food up here, and you guys are all starving, you have no food, I can either share it with each one of you, or I could just give it all to Caleb. Right?
Yeah.
Or I could give it all to Tyler and Renee.
Yeah.
Or I could give you none and keep it for myself.
No.
I have to give you a little bit actually. But the point is, the analogy is, and actually I couldn't just keep it. That would defeat that doesn't explain the definition. I can share it with you, or I can just give it all to you. I can say, here, you know what? I don't need the food. You guys can have all my food. So I can transfer it all to you, or we can all share it equally, or we can share it unequally, right? We'll talk about pizza in a second. So this is important to understand. Electrons can be shared or they can be transferred. So let's say this is a valence electron.
Alright.
If I'm going to share it with Kaylin in the world of chemical bonding, we both have to hold it. That's sharing. Okay, so we're both, like a jump ball and basketball, you both have the ball. If I give it to her, that's a transfer. Does that make sense?
Yes.
Because electrons are actual particles. So either both atoms kind of hold it at the same time, or I give it away, or I take it, right? So if I give it to him, that's a transfer. If I take it back, that's another transfer. So transferring versus sharing, it's an important concept. I think you get it, all right? And that actually dictates what type of bond. The sharing versus transfer, we'll talk about it. All right, now why does this occur? Quinn and someone else over here said that. Let's combine their answers. So why does bonding occur? It's because the atoms want to become stable. And how do they do that, Quinn?
By getting a full valence shell.
Right, atoms want to become stable by gaining or achieving. Not B. Sorry. By gaining a full valence shell. And another term for that is complete octet, meaning they have 8 valence electrons. 8 dots. Remember those dot structures? We're going to bring those back. Hold on a second. The first 5 elements, H, He, Li, Be, E, and B, they can become stable by only having 2 valence electrons. But if you only have 1 energy level, 2 is a full shell, because that first energy level holds 2. So that's how we get around the details. We just say full valence shell, and that means it's stable. So the reason everything exists is because of this. Without bonds and forces of attraction, nothing would form. There'd be no planets, there'd be no humans, there'd be no air, there'd be nothing. There's forces and bonds holding everything together. All right? And this is a huge driving force. All right? So here's the real simple definition, and then here's why they do it. Questions?
Did you mean that extra B?
Atoms want to become. No.
Sorry, I had to say something. It was
It's all right.
working in my head.
You're good.
And I wrote it down.
That's funny. All right, you're trying to take good notes. All right.
Okay, I didn't. Calling your notes good, nobody else's.
All right. So let's talk about covalent, because that's the first thing we talked about. Covalent bonds. In your homework, the goal of this sheet here is to look at the formulas and be able to tell me, is it ionic or covalent? Or both. And that's what we're going to learn right now. All right. So covalent bonds share electrons. So they share their valence electrons. But now here's the pizza analogy. Do we all like pizza?
Yes.
No.
Some people don't. You don't like pizza?
Okay, okay, you eat just plain Coke.
You really don't like pizza?
No way he's
That's fine. All right.
Have you heard the Yogi Bear?
Oh, wait.
quote?
I gotta talk to you about this because this morning the class thought I was crazy. All right. You know the 24 cut pizzas?
Yeah.
What do you call those?
24 cut.
24
Yeah, but there's another name.
Oh yeah, isn't
Sicilian?
No.
no, that's the square.
I think most people just call it pizza.
Yeah.
I just said 24.
I call it a sheet pizza.
Oh, I remember that term. My grandma says that.
Oh, you just killed me.
I'm
You just
sorry.
killed me. Because Nicole sat here and said, that's like something an old, like my grandma would say. I'm like, what do you mean? And now you just confirmed it and it's
I mean, my
on
grandma's
record.
not that old. She's like 53.
Alright, well that's way older than me.
Yeah,
But,
my
so, not way, but, significant. So, anyone else ever hear that phrase?
Yeah, my grandfather.
Yeah.
He's like 70.
What?
We're gonna get the sheet pizza.
Really?
Even my aunt says that.
My quadruple great grandpa says it.
My quadruple.
Huh. Anyways, alright, so let's say we have 24 pieces of pizza. I guess I got proved wrong on that one. How would we share that equally?
Slice and dice.
Hey, focus. 24 pieces of pizza. How would we share it equally?
Out of how many people?
Count them out.
Slice and
There's 13 kids and 14 including Nicole.
You add all the slices together and divide it all equally.
Okay, so let's just make the math easy. If we had 12 people, how would we share it equally?
Two.
Pieces.
Two pieces of
Okay, 2 each, right. Alright. Now, picture the the pieces are electrons. Okay? So when bonds form, they take those electrons. If they share equally, they split them up among all the atoms equally. Does anyone know what kind of bond that's called?
Covalent.
Valent.
It is, but there's a specific name.
Equal
Equal
sharing bond.
sharing.
Equal sharing, it's one of those words you were talking about.
Equilibrium.
Nope. You used the 2 words earlier. Right.
Non-polar.
Non-polar, very good. Equal sharing is called non-polar covalent. So, if electrons are shared equally, the bond is called non-polar covalent. If they're shared unequally, so we have 24 slices, squares, whatever, of our sheet pizza.
So
You can make-
and he gets 5.
So we have 24, right, so let's say we have 24 pieces right here, right now, alright? I keep 10, and then I split the rest up with you guys. That's not sharing equally.
No.
You understand the concept in real life. I'm just trying to give you a visual to understand the concept here. When atoms bond covalently, there's 2 ways they can do it. They share all their electrons by distributing them equally, or they share them unequally. So, unequal sharing, and that's called polar covalent. Now, if you understand what the word pole means, or polar,
Water.
this might help. Where are the poles on Earth?
North
Two
to
out.
south.
Yeah,
Top,
north-
bottom.
Top, bottom, right, sure,
Wow.
sure, sort of. The extreme, they're extreme ends, right?
It's like
One's on one side, one's on the other. Okay? So because of the unequal sharing, poles are created like opposite ends of a battery. Positive, negative. The poles of the battery. Because there's unequal sharing, it creates those poles. If everybody's sharing everything equally, there's no poles. What's at the North and South Pole that isn't necessarily at the equator?
No.
Okay?
Actual poles.
Isn't
I
that
really
where
thought
the
that
Cold
magnetic
weather.
field moves?
Yes, magnetic fields,
Cold weather.
right? And that's because of the poles and the charge. I'm trying to explain if the Earth didn't have poles, there would be no magnetosphere, and everything would be shared equally. I'm just trying to make the analogy here. And in the world of bonding, that's called non-polar because there's no poles. If there's no poles, then there's no opposite charges. Everything is spread out equally. So non-polar, they're equal. Polar, they're unequal. You don't really need to know that right now, but I'm introducing the concept of covalence, so we're going to learn it. All right, let's talk about water.
well,
How many bonds does water have in it? One
Two.
molecule of water.
Two.
2. Let's draw it. How many dots does O have?
1. And H2.
You guys just took part of my life away.
You need like you
How many valence
Six.
electrons?
Oh,
6. Thank you.
okay.
Oh,
I
thought you
just
were
said
asking
that.
someone else.
When I said dots, what did you think I
I thought
meant?
you meant
Maybe-
like
I thought you were
I
gonna
thought
put
it's
dots
literally
for.
the circle you just drew.
Yeah.
We thought you meant like.
Alright, anyways, electron dot structure. Now we're all on the same page. How many valence electrons does hydrogen have?
2. 1.
1. We put 1 here, and we put 1 here. I'm putting X's for the hydrogen's valence electron, just so we see the difference. O has 6, hydrogen has 1. I want you to circle those, bless you. That's the covalent bond. Where those two, the dot and the X, get together, they're sharing those 2 electrons. Hydrogen gets to share 2, and oxygen gets to share 2. That's a covalent bond. Another way to draw this is with lines. And I'm making the line a little bit longer to exaggerate it.
That's weird.
So that is the bond between H and O. That dot and X represents one covalent bond. It's called a single covalent bond, which we show as just a straight line. So there's 2 covalent bonds here because the electrons are being shared. How many dots does oxygen have around it? Count the X. Count the X's. How many dots? 8. Full valence shell. How many dots? Count the X's. Does hydrogen have? 2, because they're sharing them. So hydrogen gets 2, oxygen gets 2. They both own those. So they have a full valence shell. Hydrogen gets 2, that's just like helium, very stable. Oxygen has 8, and it actually looks like neon, very stable. So when they form these bonds, they become very stable. Okay. One more thing here with this, then we'll move on to ionic. Covalent bonds, a little start here, only non-metals. If there's a metal in the formula, it cannot have covalent bonding. Sort of. I'll explain at the end here. So, covalent bonds, only non-metals. So hydrogen and oxygen, water. Hydrogen's a non-metal, oxygen's a non-metal. So water uses covalent bonding. Hold on. Ionic bonds are different. Ionic bonds are metal and a non-metal. Ionic bonds transfer electrons. They do not share. So Quinn, I'll come back to you at the end here. I gotta make sure I get through this. So on your homework, you're gonna have a whole series of compounds. All you need to do is use your periodic table if you don't know where metals and nonmetals are. Metals are left, nonmetals right. Look at the formula. If there's a metal with a nonmetal, it's ionic. And you write ionic on the line. If it's 2 nonmetals, you write covalent. Very simple. Okay. Now, let's say I'm potassium.
Okay.
Here's my 1 valence electron. Eyes up here. What's my charge right now? I'm an atom of potassium. Neutral. All atoms are neutral. I'm going to transfer this electron to somebody. Nice catch. So, she was fluorine before she caught the ball. Now, I was potassium. I lost 1 valence electron. What's my charge?
Positive.
Positive. Right. Am I an atom or an ion? Ion. That's why it's ionic bonding. Okay, so I'm an ion. What type of ion? I'm positive. What's that called?
The cat.
Cation. Right, good. She was fluorine. She was neutral until she gained the electron. Now she's -1, and she's an anion. What do we know about positives and negatives? They attract. So K and F would come together to make a bond. That's called an ionic bond. So let's use that example. K gives 1 electron to F. As a result, we get K plus 1 and F minus 1. They are attracted to each other, and they form the compound potassium fluoride, KF. The reason metals and nonmetals are called ionic bonds is because the metals always give their electrons to nonmetals. Always. Metals always give, oops, that's a Q, electrons to nonmetals. Metals always give electrons to nonmetals. We'll talk more later this week as to why. Last thing I want to show you with this is the dot structure. K has one dot. I'm going to make an X for the K's dot. Fluorine has 7. There's your ionic bond. The K gives fluorine this X, that dot. As a result, F has 8 valence electrons around it, full valence shell. It's a little confusing because you can't see the valence electrons for K. They're kind of not shown. We'll talk more about that tomorrow, but that's how we would draw the dot structure for this one. I'll take the ball back. Thanks. Cool. It's all right. Yes?
What about metalloids?
Metalloids. Depends. Now, I'm not done yet.
Homework.
Not done yet. Write this down.
Gee dang it.
Some compounds have both types, ionic and covalent. I'll give you an example. NaNO3. Someone tell me, how in the world can this have ionic bonding and covalent bonding? Don't say it out loud, just think. Well, we're kind of out of time, aren't we?
Mm-hmm.
I'll just tell you. This is a metal. Hold it, give me 10 seconds. Metal, and then these are non-metals. So between the Na and the N, there's your metal non-metal. Ionic, between the N and the O, there's your non-metal, so there's your covalent. So it actually has both types of bonding. Okay, do your homework. We'll go over it tomorrow and continue this conversation.